Okay, this is going to be a quick tutorial to talk about one of the fundamental data structures that we're going to use just all the time. It's so useful, really useful for doing data operations and so forth. And it's the data structure, the array. So if you're on the module homepage, we're just going to go to our tutorials, and we're on week 3, and you can access the arrays, and the link to the video will be up there shortly. Okay, so if we're talking about arrays, we're talking about a couple of points that we want to make. It's one of the very fundamental of the data structures. It's holds values of the exact same type at continuous memory locations, like we talked about in the lecture. And we can think of it with different metaphors. I'm going to go through a metaphor here that likens it to post office mailboxes. One of the metaphors I like is that of a street with houses on the street. Each house might contain some number, like 73, 72, 33. And the address of the houses is the index by which we access our number. And if we have an array, that point about the memory is that the length of the array will determine the number of bytes that are contained in memory. So, if an array is like a box of contiguous space in memory, a mail bank in a post office box is kind of like a space on the wall with little boxes. And the array has been partitioned into small, identical sized blocks. We might call them elements if we're using the technical language, whereas the post office boxes are small, identically sized boxes, and we call them post office boxes. Now, each of the array units can store a certain amount of data, and each of the post office boxes can hold a certain amount of mail. And all of the same data types will go into each of the boxes in a particular array. So you could have an int array, you could have a character array, but all of the boxes, all of the addresses in that particular array have to be of the same type. And likewise with post office boxes, we're talking about mail. So letters or packages, and they all have to, that's the only thing that goes in them. And we can directly access the contents of an array with their index, and likewise for a post office box through their mailbox number, or if we're using my metaphor of the street, by their street address. Okay, so in C, the elements of an array are indexed starting from 0, just like the other counting we've talked about. And that really, this fundamental feature of arrays, that's why in this programming language you count from 0. Not all languages do that, but a lot of the traditional ones do, and it's a way of thinking you get used to. Now, if an array has some number of elements, it could be arbitrary, like n elements, the first element will always be located at index 0, and the last element is always addressed to n minus 1, the number of elements minus 1. Why? Because we start at 0. So this makes very, very good sense. Now, C, even though it seems, all programming languages are very specific and, you have to get them technically right, but C is considered very lenient. It won't prevent you from going out of bounds of the addresses you set for an array. And, this is definitely going to cause you trouble. So you have to pay attention to details like that on your own. So C is very lenient, but then if you want to do something with the leniency you're afforded, you're in for trouble. So you got to be careful. The way we declare an array is we declare the the type first with a type declaration. We set the name, and in square brackets we assign the size. And we might declare an array like this outside of a main function, but to assign values, if we're going to hard code the values, they have to be inside of a main function. So the type in green is what kind of variable each element in the array will be. The name is, what you want to call it. The size is how many elements. So here's an example. let's say we wanted to store all the grades for an assessment. There's 40 students in the class. We might say if they were whole integer grade awards from 0 to 100, let's say, we might say int student underscore grades 40 in square immense. So this is how we declare the array. Got a little example I'm going to go through. Open up the sandbox. See if we can keep working here. I'm going to have to restart. I was afraid of that. Let's just give it a moment. It should start up pretty quickly. There we go. There we go. There we go. So what I've done is, if you kind of look over here, I'm arranging my sandbox to have a tutorials folder with the different weeks, and inside the weeks, if you want to follow along with me, you might do something similar. I would definitely recommend making your own folders for the notes and, maybe for the lectures as well. So the first thing we're going to need to do is to cd into tutorials in week 3. Oops. What did I do there? There we go. Oops. I'm already in tutorials. CD week 3. There we go. All right. So I'm in there. I've set up this little program. It's got the standard IO because I'm going to use the printf function. And I just want to go through one example where this is an example from the notes. If you read the notes and ran the code, you might have seen something like this before, where I'm declaring 3 integer values. I'm calling them grade 1, grade 2, grade 3. Then I'm setting up a main function. And inside that, I'm using printf. I'm going to print out the average grade of my 3 grades in my first 3 assessments. Did well on 2 of them, did poorly on a third. And I'm asking for double quotes, average grade, colon, space, and then I'm asking for a %d, which is a decimal value, and \n to make a new line. And then all I'm doing is I'm manually calculating the grades. I want to do the arithmetic on the grades, adding them together, grade 1, grade 2, grade 3, and I'm going to divide them by 3. Need to put the parentheses so the order of operations is correct here, just like on a calculator. So I'm going to make arrays. See what happens. Success, grand. And my average grade is 59. So the average grade is 59, but I want to make sure that that I get any decimal value to get as much grade magnitude as I can out of my grades. And a decimal value that I've asked for here is going to round down, and I've divided these decimal values by another decimal. So a way we can manage that is we can change that to a float. And let's see what happens. I'm just going to save that, make, and I get an error. Why do I get an error? I get an error because I'm trying to do a mathematical operation on all integer values, and I've asked for a float outcome. So a way to mitigate this mathematically so that C is happy is to use any decimal value. You can mix and match integers and float values, but we have to have at least one. So here I'm just going to divide by 3. I'm going to save it. Note I changed the variable type I'm asking for to a float. And I'm going to make arrays. This time it compiles no problem. And this time I get my 1/3 of 1 point back. That's fantastic. Now we want to demonstrate an array here. So I'm just going to do this. Shift-Alt-A to comment that out. Come down here. I've written another little version of the program. Shift-Alt-A to uncomment it. Now here what I've done is I have included standard IO again because I'm using printf, and I have declared an array. Now why have I declared the array? In what way have I declared an array? Well, I hope you can see that I've included the type, I've included the name, and I've included the number in square brackets for the length of the array that I want to set aside memory for. And I've done that outside the main function. Then inside my main function, I've defined using the address here, grade bracket C close bracket, and I've assigned those 3 values. And then when I calculate my float value for my mean, I've used the address, recycling the name of the array. Now we could do some other fancy things. We could add a loop in there, like a for loop, and replace the numbers here with I and cycle through different values of I. I'm not going to do that here, but it is demonstrated. Something similar is demonstrated in the lecture notes, and I encourage you to do it. So I'm just going to save this up. I'm just going to compile my program again, no warnings, boom, and I get my average grade of 59.3. I hope that is a demonstration of the code, and I hope you find this useful, and that's all I have to say about that.